Okay, so we're going to move on from special right triangles. We already talked about the 45, 45, 90 triangle. The 30, 60, 90 triangle is just another triangle that we're going to kind of mess around with. And then I need you to memorize it. Yes, you have access to all your notes during quizzes and tests, but this is something that is almost like multiplication tables when you're like in fifth and sixth grade. It's better for you to know them and memorize them, to make sure that you are like you have access to it, right? I don't want you to get to a quiz, and you guys just took a quiz, right? And you don't want to be timed on something and you're sitting there looking up and trying to understand. This needs to be in the forefront of your brain, especially for those of you who want to move on, past integrated 3, perhaps calculus or some higher level math. Absolutely. That is fine taking notes. That's perfect. Okay, so this one says, so draw a 30, 60, 90 triangle and then assign a specific value to one of the sides. Now that you have assigned a specific measure, then you're going to try to calculate the rest of the two sides. So as a reminder to you here, we took a 45, 45, 90 triangle, and then someone remembered the isosceles triangle theorem, actually the converse to it, where you said if the angles are congruent, then the sides opposite those angles in a triangle are congruent, right? Other people use the fact that it was half of a square, and then you realize that all four sides were equal, and then you use the Pythagorean theorem to find the hypotenuse. Okay, same thing here. Obviously, you're not going to be using a square, but you are going to be doing this. So when I draw my 30, 60, 90 triangle, looks like this. And then this is my 60-degree angle. This is my 30-degree angle. And because it's a 30-degree angle here, obviously it's smaller than this guy. So that's why my smaller angle goes here. And then I'm going to remind you of our conversation all the way back up here, which I can't scroll. Come on, little mouse. We talked about, remember, we said that these were my arms right here. And I talked about how when I put my arms closer together, this side that connects the end points of my fingers gets smaller at the same time as the angle between my arms gets smaller. So this is something that I want you to play with, right? Like I hopefully, maybe not right now because you're in front of all your classmates, but maybe like you take your arms and you open them wide and small and you realize like the length between your fingertips is getting bigger the bigger my angle is, and smaller when my hands are closer together. So same thing goes here, and same thing is true for your triangle. Look, big angle, opposite side, longer, really long, gigantic long, right? And then really, really small angle and really small side. So hopefully you're seeing this truth, right? For those of you who did not do so well on that first quiz, geometry is one of the most applicable maths that we can talk about. So here, because it has a smaller angle, right? This side is the shortest side. Because it has a longer side here, also known as your hypotenuse, he's probably across from the biggest angle, which he is, okay? So they said to use any number, so let's all choose the same number so we can do it. So what number do you want to use? Just throw a number in the chat, doesn't matter. Good, 10. Now, I'm just going to use the number 10. And then I'm going to throw, let's put the 10 right here. So it'll make sense because I know where we're going. Can you put the 10 here? And what I'd like you to do is I'd like you to figure out another shape that would help you figure out the rest of these sides. Okay. Now you can Google 30, 60, 90 triangle. For the most part, I think the 30, 60, 90 triangles may help you if you understand proportions. Get to this number, to the other two numbers here. But I want you to think for just a second, what other numbers do you want to, like, what other numbers do they have to be because this side is 10? Okay, so take a second, let yourself feel a little bit uncomfortable and be like, what the heck are you talking about? So what other shapes are there that would help you do this? Okay, here's a square, right? Yeah, someone says rectangle. I'm just going to tell you right now, rectangle is not necessarily going to help you in this example. So I'm going to pause it just so you guys can think about it. All right. So um, some of you said, oh, we can put a triangle on the other side. Depends on how you put that triangle. But I will show you the other triangle that I was thinking. I would go this way. And then what triangle do you see here? Be very specific. What triangle do you see here? So I'm imagining this exact same triangle reflected down. What kind of triangle is this? It's actually more specific than that, but very good. Someone said this is an isosceles triangle. Can you guys tell me the measurements of each of the angles? Because that'll tell you what kind of triangle it is. That's actually where you should be going. Yeah, it's an equilateral triangle. Perfect. So here, if it reflects down, this is 60 degrees, this is 30 degrees, but the whole thing is 60 degrees. What do you know about this kind of triangle? This is technically the way you guys, I shouldn't have said equilateral. I should have said equiangular. Equiangular means all three angles of the triangle are congruent, right? 60 degrees, 60 degrees, 60 degrees. So what's something that you know? Look here and tell me something that you know. Specifically sides. That's what we're looking for. Okay, so I'm going to do a regular reminder. If you're worried about your grade right now, try your best to let that go and focus on your learning. Because when you're focused on your learning, you're not worried about being wrong. I just want you to try this. So this is 10. Very good. So since this is 10, what else do you know? Someone just said it. This has to be 10. Is that true? Do you agree with that person? Do you agree that if this is 10, this has to be 10? Yeah, it has to be. Okay, what else do you know? This is geometry right here. So if you know that that is true, what else do you know? Which sides are equal? Yeah, this is 90 degrees, someone said. Good. What else do you know? Yeah, this whole side would be 20. Sure, that's good. Thank you. Yes, very good. The other sides would be 20 as well. Perfect. In our okay, so for those of you who are like a little bit lost, our whole goal was to find more of this blue triangles information. Whenever I ask you to solve, there's something called solving a triangle. That sounds weird, but I'm asking you for all angles, all sides. So did you just find another piece to the puzzle? Very good, by the way. Super impressed with anybody who just said that this was 20. If you didn't say this was 20, just be like, dude, why didn't I know that was 20? If you don't know why this is 20, hey, why is this 20? Why does this have to be 20? Yeah, 10 plus 10 is 20. Good. Yes, because this was an equilateral or equiangular triangle, which means since all three angles of a triangle are congruent, then all sides of the triangle are congruent. Got it? I'm going to say it again. Because all three angles of the triangles are congruent, then all three sides of the triangle congruent. The moment that this one person said, hey, since this is 10, this is 10. I said, yeah. And they're like, and this is 10 and this is 10, so this has to be 20. And I said, yeah. So what else do you know? You said, oh, because this is 20, this is 20, this is 20. Okay, so if you couldn't follow that, if you didn't follow that right now, that's all right. But you got to get in here. Does that make sense? Yes? Can I see nodding heads? Some of your heads aren't nodding. Look at your classmates' heads, guys. Some of you are not nodding. Okay. So with that being said, so imagine now I'm trying to find more information of the blue triangle. What am I missing? What am I missing now? Yeah, I'm missing this guy. Do I have enough information for me to find this guy? Do I have enough information to find this guy? Yeah, very good. Okay, how? How would I find it? Now, this is your job. I'm going to pause it and I'm going to let you guys find it. Pause and find this other side. This other side. You all have enough information to find that other side. If you are sitting there going like, I don't have enough information, yes, you do. You have to find it. So exactly, some of you got that answer perfect. Very, very strong work right there. When you're doing this, remember, whenever you have a right triangle, there's two paths your brain should go. Anybody remember the two paths that I was talking about last time? One of them is the one that you just used, which is the Pythagorean theorem. Very good, strong work. And the other person said trig. Very good. So sine, cosine, and tangent. I haven't really talked about trig, so we just imagine Miss Johnson is not going to make you use trig until we review trig, right? So yeah, exactly. So you should have used the Pythagorean theorem. A lot of you got the answer perfectly. Some of you wanted to plug into your calculator. You won't see me plugging into the calculator for the specific reason. We want exact answers. And the moment that you hit enter on your calculator, now you have an approximation. Okay. So I'm going to plug in my Pythagorean theorem. I would have gotten 10 squared plus leg squared equals 20 squared. Does everybody see that? So here's my triangle that I'm talking about right here. Boom, 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 right? So here's my leg that I'm looking for. So that's 10 squared plus leg squared equals 20 squared. For those of you who didn't have this written down, why not? Okay, why not? So make sure, I keep saying this, this is the lesson. This is like the lesson. Okay. So can you really think about 6th grade, 7th grade, 8th grade, not knowing your multiplication tables? This is that lesson. Okay. So this is 100 plus leg squared equals to 400. So I get leg squared equals to 300. Everybody okay with that? And then I take the square root of both sides, right? And I get leg equals to plus or minus. And then I'm going to break this thing down. Do you want me to break it down? Or are you guys comfortable with me breaking it down and you guys checking back later? Break it down? No? Yes? Yes. Okay, good. So if I break down square root of 300, it looks like this, right? So I say, hey, what times what gives me 300? What times what gives me 300? Someone said, okay, very good. 100 times 3. And then I go, okay, well, what times what gives me 100? I already know 3 is prime, meaning I can't break it down, right? So what times what gives me 100? Yeah, 10 times 10. I'm always looking for pairs. So since I have a pair, I'm just going to stop. So this is 10 root 3. 10 root 3. We talk about how we have to put plus or minus. I will always write this here because I can't not write it because most students forget about it because their calculator doesn't tell it. So I'm going to always write this here for you. Okay. So plus or minus 10 root 3 is the solution to this equation. But we throw out the negative because we don't have negative side lengths of a triangle. And then in a little bit, we will. And then you'll be like, Miss Johnson, I thought you said. But it's not really negative side lengths. It's actually direction or position. So there goes that, right? There goes that. And then your brain should have said like, I wonder what the relationship is between these three numbers. Like, was it a coincidence that this 10 is that 10 and we relate it to 20? Is it a coincidence? And then, so if you're not sure if it was a coincidence, you would kind of study this and be like, oh, where did that 10 came from right here. And when we subtracted it from here, oh, so it's not a coincidence. So generically, I want you to build this triangle using x's. I'm going to do it, but I want you to try it. So I'm going to build a generic triangle. So generic means that I'm not labeling it. I don't know why I'm still in highlighter mode, but that's where we're at. I want you to build this triangle using x's. And I'm going to put an x right here. And I'm going to put an x right here. I want you to build. Now, how would I find this side? So your brain needs to go back here where a bunch of my students talked about, oh, that means that, and that, and that, and that, and that. And then build this side according to it. Okay, I want you to build this generic triangle and be wrong. It's okay to be wrong. If there's one thing that you can learn in this class, be wrong, make mistakes, and then learn from them. Okay? Yeah. You had it in the wrong spot. Perfect. So that right there, when you just made that mistake and you reflected and you're like, oh, shoot, that's why it's wrong. That's what makes it do you see how that is where the learning is? Not necessarily getting it right. Okay, so take a second, fill this out. Good. Okay, so I asked you to, can I generically, this is the stretch that math is helping you do. Can I apply this truth generically to this triangle? So we talked a little bit about logic while we were on pause, but can I apply this truth? Now, some of you figured out that this side here was 20. And if you rewind back, you figured out it was 20 because this was 10 and this is 10. Can you imagine me drawing another triangle here? What would this length be here? Yes. Very good. I need a couple more people. Not x squared. It would not be x squared, but I understand what you're trying to say. Yeah. It would be 2x. Okay, so 2x. So Miss Johnson, always for a 30, 60, 90 triangle, absolutely. For a 30, 60, 90 triangle, you're going to have x be your short side, right? Does everybody see me pointing at the smallest angle and the shortest side? Your longest side is going to be 2x. Now rewind back. Why did we get 10 root 3? Rewind back, and why did we get 10 root 3? And then if it's true, what would this side be? Generically, what would this side be? Yeah, that's how we would figure it out. But what would this side length be? Like, look at the pattern here. And then just give me your best guess right here. Just best guess. Best guess. Yeah. Very good. It would be x square root 3. So if there was something that I wanted you to take away and really own for this lesson, it's this. X, 2x. This is going to say x root 3 when it catches up, y'all. X root 3. So for those of you who labored with me right now, you should never forget why this is x and why this is 2x. Because you guys got that, right? Some of you, because you labored this part with me or on your own, some of you did this with me and some of you did this on your own, you should be comfortable with this being x root 3. Now, in the chat, someone had said, hey, Miss Johnson, this one has an x root 3, but this one has an x root 2. Definitely. So if I'm in x root 2 land, your brain should be in 45, 45, 90 land, right? If I'm in x root 3 land, your brain should be in 30, 60, 90 triangles. So these two triangles right here and right here need to be in the front of your brain. So for now, my suggestion is when you do this problem up here, your exit ticket, I don't know why it's so hard for me to scroll, but it is. There it is. There. You should be seeing, oh, that's x root 2. And that's x 2x x root 3. So you are completely able to do this. If you haven't memorized these, my suggestion is at the top of your paper, you draw those two triangles out and you label them so you can use them. pretty soon you won't have to draw them out because you'll have them in your head and you can use them. All right, let me stop right there.